All right, welcome everybody. Welcome to part 9. All right, before I officially get started, as always, I'm going to wait until about 3 minutes after, and then I'll officially go ahead and kick it off. Okay, so welcome everybody. Come on, trickle in, and eventually we'll go ahead and kick this off. Also, if you're not in the SANS Discord server for the workshop channel, please go ahead and join there because that is where any questions, Q&A, comments, anything like that you might have as we go through this part of the series, that's where all that stuff will take place. All right, welcome to those who are just now coming in. Giving it till about 3 minutes past to allow some more people to trickle in, and then we'll go ahead and kick things off. While you're jumping in, if you don't have Wireshark, please go ahead and download that. We'll use that a little bit today to help validate some things that we're going to be creating. You don't have to have Wireshark up and running. It's just a nice to have little feature for this part of the series. Good question. Also, I don't mind if you send me a direct message in Discord. I'll try to check that a little bit as well. But feel free to use the public channel, the workshop, um, unless you really don't want to. Okay, so that's fine. I'll check my DMs every once in a while. But the question I got in the direct message was, will we need anything from any previous parts of the series for this one? The answer is no. We'll be starting from scratch for this part of the series. Cool. And we are 3 minutes past. So welcome everybody for coming in and tuning in live to part 9. This one, if you couldn't tell by the tagline, can you see the internet? All right, I got tons of terrible nerd jokes, right? So I'll be here for a couple hours. We can have some nerd jokes. All right, so can you see the internet? Okay, so what we're going to be covering today is I'm going to talk about 2 of the most popular libraries to use in C for Windows, obviously, for how you communicate with an internet resource or with the internet in general with HTTP. Okay, so a lot of times, especially if you are creating an implant or malware or whatever, you will have to be able to communicate to something. It's best to communicate with something, right? Your C2 infrastructure, whether that is going to be Cobalt Strike, could be Empire, Covenant, Sliver, Havoc C2, Posh C2, Mythic, right? There's tons of them. All right, so check out the C2 matrix if you want to see the full-blown list of C2 frameworks out there. But what I'm going to cover today is we'll look at a comparison that MSDN has made for the 2 libraries for HTTP comms. And then I'll give you a little teaser towards the end of how you could possibly turn what we just talked about, what we just did today, into a little stager to pull down something from Sliver and possibly execute it all in memory. Okay, so we'll take a look at that at the end. All right, so let's go ahead and dig in. All right, let's talk about these two libraries for HTTP communications. All right, so MSDN here, let me go ahead and give you all this link inside the workshop channel. All right, that way everybody has it. MSDN has a little comparison chart with WinINet and WinHTTP. All right, so WinINet is basically just the Windows Internet, if you will, and in my opinion, it is far superior to WinHTTP. Now, you might see that MSDN, they also have an opinion on which one you should use as well, and they say, hey, between the two, you should use WinINet. Now, they do have a caveat to that where they say, unless you plan to run within a service or a service-like process that requires some kind of impersonation or some kind of session isolation. Then they have a pretty good breakdown of the different features that WinINet has and what WinHTTP has. Okay, so you can go through and read those on your own time, but what I'm going to demonstrate and have you all walk through with me is how to make an HTTP GET request using WinINet. All right, so cool. Before I leave off this page, on the left-hand side, there's other subcategories or chapters, if you will, for WinINet. Okay, if you're brand spanking new to WinINet, I recommend that you go through, some of those chapters at some point in time. I do think they're pretty informative, especially, like I said, if you've never seen some of the stuff before. Cool, so let's jump in, shall we? Okay, so one of the first things that we have to do inside of our project is to go ahead and add some source code files. And what I would like to do is just share with you kind of my methodology or my process of when I'm trying to create something brand new from scratch, right? Some kind of standalone capability, which is what we're creating right now, a standalone binary that is a capability for HTTP communications. And then I'll kind of show you how you could bring some of this into a larger framework that could be used to create a full-blown implant that has HTTP communications. Okay, so I have my Part 9 project here, and we're set up for debug 64-bit release, cool, and then source files. So we'll go ahead and add a new source file here. As always, change the extension. We're not doing CPP yet, that's coming in later. That'll be a whole different series. So I'm going to rename this to main.c. All right, cool. Now, before we do anything, again, I just want to give you a little bit of insight into how I go ahead and start creating a project. So I want to do something a little bit different with you all for this part of the series. And that's, I want to show you all how to make more reusable code, how to make it a little bit more formal in the sense of making sure everything is in the proper header file, and make sure that any functions that we declare in header files are defined in the source code file, and also making wrapper functions around some of these WinINet APIs. All right, so my thought process when I get going with something is I'll just start typing out some comments, kind of like, what is it that I need to make for this? All right, so you don't have to follow along with me and type this all out. This is just me sharing with you all my process. Okay, so one of the things I know we're going to need is we have to have some kind of capability to start the internet session. All right, so that comes from MSDN documentations, MSDN documentation for WinINet. Okay, there is a certain function call that we'll get to here in a second that basically initializes your program and bring in other DLLs, initialize various structures and whatnot for your program to basically say, hey, my session for the internet has been created, and I can then use that session handle for subsequent function calls. All right, so we need to create some kind of function that can start the internet session. And then we'll need some kind of API that can allow us to make a request. All right, so we'll talk about that here in a second. Okay, so we got that. Then after we make a request, we'll have to create another function that should be able to send off the request. So we send it off, cool. Then what? Okay, did we fail? Is it good to go? Did data come back? What do we do next? So the next thing that we could do is create a function that will process the results. And then, of course, we want to have some kind of error handling baked into this. And you'll see here in a second how the error handling for WinINet can be very specific to WinINet. Okay, so I'll show you how to create a wrapper function, if you will. That way, if some kind of error does happen, we can make better sense of what the error actually is, right? And I'll intentionally show you some errors, or hopefully try to generate some errors when we're going through this code. Okay, so that's kind of what I think about a little bit of what I'm trying to create something from scratch, okay? Trying to think of my overall objectives, what I'm trying to accomplish here. And then obviously there would be a more formal design process that would actually take place with your whole team to make sure that you're hitting everything you want to hit. Okay, so I definitely recommend that you don't just start coding like crazy. Okay, so think about your end objective and have some kind of design phase, if you will, to make sure you're hitting everything that you need to hit. Okay, sweet. So let's go ahead and jump in and get our main source file here, ready to rock and roll. Okay, just like every other part of the series, we have to include certain files or certain headers. Okay, so let's go ahead and do that. First and foremost, let's include Windows. Windows.h. Okay, we'll bring that all in. And then what I like to do, I like to make a little pound define around the cDuckle calling convention, create a little macro. And then we'll go ahead and create our main routine. And I'm going to put void in there because we are not going to have any command line arguments. Okay. Also, please let me know if I am going too fast for those that are trying to follow along with me live. Okay, so I'll try to definitely slow it down. I know that was some feedback from the last session. Say, hey, can you not go so fast? And yes, I can slow it down. So yeah, absolutely. All right, and then I'll also try to explain a little bit more about what it is that I'm trying to develop as I go and make some of these functions. Okay. All right, so inside of my main function body, one of the things I always like to go ahead and create right off the bat would be a variable that can hold like a return value, a return status code, if you will. Okay, so I always like to use a double word, which is an unsigned long. So I'm going to say last error, and you can, doesn't matter if you put the OR at the end. I think it's pretty obvious what that variable is going to be used for. Then I'll just come down on a few lines. Oh boy. All right. Sorry about that. Zoom just crashed on me. All right, can I get a quick check, y'all, to see if I'm good? All right, thank you, TPZ. I'm back. Yeah, that's the first time Zoom has crashed on me. Very interesting. Have to look at that later. Okay, all right. Where was I? Okay, yes. Trying to talk about building and compiling as you go through some of this stuff. That way, you're not spending days, weeks, or whatever creating new features, creating code, and then you go to compile, and it's like you get just hundreds of errors. Okay. All right. So sweet. Let's go ahead and move on. So what we're going to do next is, because we're going to use HTTP communication, we are going to have to specify some kind of target. All right, we need to communicate with something. So right now, I'm just going to play around with localhost and see what happens there. All right, there's a few things we need to create, a few specific type of variables. All right. Did I freeze again? Is everything going good? Somebody with me? Okay. All right. Sweet. Awesome. All right. Thank you. Okay. Yes. So we're going to need to create a few more variables of specific types. Okay. Types are specific for WinINet, right? So the type is going to be H internet. Okay. So at this point in time, instead of me creating everything inside of the main function body, I think what we need to do is to go ahead and make a specific header file where we can start to declare some of this stuff. Okay. So let's go ahead and do that. So go to header files and click add new. And for the name of it, I don't care what you name it, as long as you know what it's going to be used for. I'm just going to call mine HTTP APIs. Yeah, why not? Okay, so pragma once is there. Awesome. Okay, and then also we might as well go ahead and include windows.h here as well. All right, that way we can have all the standard Windows data types, but Windows.h doesn't give us everything that we need for HTTP communication. Okay, and that's because it doesn't know if you want to, if you want to bring in WinINet or WinHTTP libraries. Right, so that's where we have to get specific here. So let's go ahead and do that. Let's include WinINet. All right, so WinINet.h. Cool. And to help us out along the way for status messages and stuff like that, let's go ahead and use printf. So let's go ahead and include the standard IO header file as well. Okay, cool. All right, now what we can do is we can start to look at how we can create some of these wrapper functions. Okay, so remember some of my notes that I created real quickly. We have to create some kind of function to establish the session for our internet for the program. So let's go ahead and create a wrapper for that. So when I go through this, I like to have a standard convention, if you will, for my wrapper functions. I always like to return a double word value because I use that as the get last error or whatever the error message or error number might be for any kind of function call, and I'll return that. Anything else can come from a different parameter for the function. Okay, we'll get to that here in a second. All right, so let's keep going with this one. So double word, win API, which is standard call. And then we'll say init session. Okay, so init session, one of the things I want to have for this function is I want to be able to pass back, if you will, the handle to the internet session for the program. So what we can do is we'll say, hey, we're going to use the sal annotation out. Okay, so this is a pointer that we're going to be assigning and writing out to, if that makes sense. Okay, so that's what the sal out annotation is reserved for. So we'll say ph internet. All right, so lph internet, my bad. And we'll just call it h session. Okay, so again, this is going to be a pointer to the session handle for the program. Okay, so inside of this, I actually need to get rid of that because we don't make the actual definition in a header file, just the declaration. Okay, and as you go through and make this, you'll notice a little green underline here, and it says the function definition for init session is not found. So you can go through, click on the little paintbrush thing, and you got two options, right? Create the definition or copy the signature to the clipboard. So I'm going to try to create the definition. Let's see if it does it. Of course. Yeah, unable to create the function. Fine, whatever. But it was copied to the clipboard. Okay, cool. All right. One thing that it did do is it created a source code file for me. However, it's not of the right extension. For whatever reason, Visual Studio has no idea that I'm trying to create a C program, not a C++ program. So shame on you. All right. And also, we need to have the include for our HTTP APIs. And I think it says it's in the clipboard, so let's see. Okay, yes, it is. It's in the clipboard. One thing that stinks, though, is when it comes in from the clipboard, your formatting and stuff doesn't stick, okay? So just for me, just for my coding personality, if you will, coding preference, is I like to bring things down on new lines, even if there's only a single parameter for a particular function. And then it automatically recognized I was using a macro for win API, which is just standard call. So it's like, hey, I'm just going to put standard call. So up to you if you want to change that back to win API or leave it as standard call. Okay. All right, so let me go ahead and split my view. That way I can show you, and you as well, you can do this too. So you can see source code files and header files at the same time. So I'm going to click on this tab. All right, so right click on it and choose new vertical document group. And I'm going to hide that for a second. Okay, I'm going to drag main.c over here. I'm going to wait until it turns all blue. Okay, there we go. So the thought process here, my workflow, my window workflow, if you will, is I like to have headers on the left and source code files on the right. You can do this too if you like, if you have the real estate space on your monitor. Otherwise, keeping it all at the same time or in the same window is obviously more than okay. Sweet. Save these files here. Cool. All right, now what I'm going to do is I'm going to go ahead and try to build this program, and I'm hoping that we get some errors, some bugs, some warnings, stuff like that, because I want to show you something real quick. So I'm going to build it, Control B, go through the process. Okay, it says warning, H session, unreferenced formal parameter. Yes, okay, that's fine. Let's see if we can generate some more warnings here. I'm going to right click on my project, go down to properties. Okay, so this is the project properties here. The warning level, all right, it's already set to 4. Okay, warning level 4. All right, so we're getting the most, if you will. Okay, and let's see, what did it say, the output? Okay, unreferenced formal parameter, that's fine. We can take care of that real quick. With unreferenced parameter, I don't think I've talked about this yet. Unreferenced formal parameter basically means you're referencing it. If you hover over the macro, you'll see that it expands to the parameter name and then just parentheses around that. Okay, that technically is a reference, but you can see the name of the macro here. It's unreferenced. All right, so we're not actually doing anything with it yet in the function, which is fine. So let's go ahead and save it and build it. See what happens. Okay. All right, so nothing yet. Okay. You will see though that init session has a little green underline underneath of it. So if you hover over that, it'll say, hey, you have inconsistent annotation for this particular function. It says this instance has no annotations. So what in the world does that even mean? So if you go back to the header file over here, we have an annotation used for this parameter, and it's out. Okay, there is no annotation here. And I don't like to add them manually here. What I do like to use is another SAL annotation called use decal annotations. All right, so use decal annotations basically says wherever this particular function, wherever this has been declared, go ahead and use any annotations that it has for function parameters and apply those to this function here. Okay, so I'll go ahead and save that. And eventually that green line should go away. Maybe. Maybe not. Oh, way to go, Visual Studio. Come on. Nope. Oh, whatever. Okay. It should go away, okay, because we are using the same annotations over here as we are here, okay? Because we say use the declared functions annotations. Sweet. All right, now there's one thing though that we didn't do yet. So for WinHTTP and WinINet, a lot of times there is a specific library file that you have to link against. And let me see if we can go just a little bit further to see if we can generate that error message. Okay, so let me go and grab something that you all are going to need for this next piece. How did I separate them? You mean the windows? Is that what you mean, TPZ? Yeah. All right. So any tab for anything up here, just right click on it. All right. And then we'll, of course, already have the window split. But right click on a tab and scroll down to the bottom. You should see some kind of split. And depending if you want it vertical or horizontal, it's up to you. There's also a vertical piece that can happen on the right. If you go up here on the far right, there's like a little arrow up and down. You can just drag that, just click and drag, and then you'll have an automatic split that's horizontal. If you want to do something like that, you could but that's up to you. Did you get it, TPZ? You got the vertical split or horizontal, one of them? Maybe you're doing both in some kind of crazy fashion. Okay, so what I gave you in the workshop channel is a user agent string. Okay, so that is what we're going to use for our HTTP request, right? So make sure you go ahead and bring that into your code. We'll go ahead and get that ready here in just a second. Cool. All right, so we can go ahead and get rid of that because now we're gonna go ahead and use that parameter here. So let's go ahead and do what we did in main.c, where we go ahead and create our last error variable. And we initialize it. We always initialize our variables. All right, and then we go ahead and we return that. So now, how in the world do we initialize our session to the internet, if you will, all right, for this program? Okay, that comes with a function call named internet open. So internet open, and you'll see that if you just tab complete internet open, I can put a semicolon right there. It's purple, right? Purple typically is reserved for macros or like constants or other kind of stuff like that. So if you could, you can click on it and just hit F12. Okay, so F12 will open up the WinINet header file. And you can see that this is indeed a little macro, if you will. And what it's doing is it's checking to see if Unicode is defined for the project. If it is, then Internet Open is basically going to be an alias to Internet Open W. And then, of course, the opposite, if Unicode is not defined or if Unicode is not supported for your project, then Internet Open is just going to be an alias to Internet Open A. Okay, is the A being for like the ANSI standard or ASCII, if you will, multi-byte character string. And Internet Open W will be the Unicode or the UTF-16 standard. Okay. All right, so I'm going to go ahead and close that. And I don't like to use those macros. I like to be explicit with which one I want to use. So I'll tell you why here in just a little bit. So we'll go ahead and call Internet Open A. And if you have no idea what Internet Open A is going to be, what kind of parameters and stuff like that, you can go ahead and hit F12 again, and you'll see the declaration for it. Okay, so you can take a look at this and start to look at these parameters, and you can already start to know how they're going to be used, also how you should pass things in to this function. Okay, so everything here is in, right? An in. Okay, so the in means you pass it in. The data is going to be read, but not written to. Okay, so that's where something like an in out could be. An in out meaning I'm going to try to write to a data buffer or write to that pointer to give you some kind of value. The in opt is optional. You don't have to pass in a legitimate value for these parameters. Okay, that's kind of cool. So the agent string, the user agent string, is optional. We can pass in a null pointer for this particular parameter, and Internet Open A should be checking to see if we passed a null pointer for this one or not. So we actually will go ahead and use a user agent string. Okay, so it needs a pointer, right? A constant pointer to the user agent string. Okay, then we have an in, which means read only, the access type. And then two optional parameters, pointers for proxy information, proxy bypass information, and then the last one being for flags. Okay. All right, so that's how I look at a function declaration from a header file. So let's go ahead and check out what MSDN says about it. All right, so Internet OpenA says that it initializes an application's use of WinINet functions. And then it gives you all the parameters here. But what I don't like about MSDN documentation is the lack of specificity for the style annotations. Every single one of these, it just says in. And if you look at it at face value like that, it makes it seem like everything is required, that nothing is optional, when that's not true. So if you're ever curious about what the actual truth is for a function and its parameters, look at the Windows header file. Try not to pay attention to MSDN documentation, okay? Because sometimes they could misguide you, if you will. Okay, so yeah, the agent, okay, so that is going to be, that's going to be the user agent string. Okay, the access type, okay, this is say, hey, a couple of flag options. Enter open direct, say, hey, all host names locally, type preconfig. Okay, so retrieve the names from the proxy or direct configuration from the registry, and a couple other flags. Okay, so proxy and proxy bypass, I'm not going to be talking about those. So those are going to be just null pointers for us. And then the flags can have any kind of bitwise OR combination of these flags. Flag asynchronous from the cache. Okay, so basically say, hey, I want you to look at the cache first to see if we already fetched this resource. If so, we're not going to go out and make another one. We'll look in the cache first. Okay, and then flag offline. And the return value. The return value here is a valid handle for the application that we'll use for later on function calls. And if it says, hey, if this fails, it returns null. And then go ahead and call get last error to see exactly what failed or exactly why it failed. Okay, cool. Go ahead and close that. And let's go ahead and build this out. Okay, so this returns a handle to the session. Cool. That's what's being passed in for this parameter. So what we can do is we'll go ahead and say, we'll dereference that pointer coming in. And some people might think I'm crazy here because I'm not doing a check to say, hey, John, you're not seeing if you actually have a pointer. What if somebody gives you a null pointer? Okay, well, based on the style annotation, that is not an option. Okay, it is not an option for you to give me a null pointer. So I technically don't have to do a check for that. If you're being a little bit more paranoid, then yes, obviously you would do a check for null pointer. If you did out optional for something like this, that is saying, hey, whoever is calling me, I'm giving you the option to pass a pointer to this parameter or not. Okay, so that's when a null pointer would be an allowed value, if you will. All right, so anyway, we'll go ahead and we'll dereference that pointer to update it with our handle to the internet, if you will, or handle to the session. Okay, so it wants our pointer to the user agent string. Okay, so what we can do though is we don't have to go around and make an actual variable with that. We'll just go ahead and use the string here like that. Okay, it's cool. I need a comma down there. Sweet. Can I paste that URL? That is not a URL there, TPZ. That is a user agent string, and you already have it. Or what URL? Oh, MSDN. Sure. Yeah, there you go. There you go. My bad, my bad. Sweet. So we have the UA string. Awesome. Now the next parameter, and my IntelliSense went away. So I'm just going to go back here and delete the comma, type in the comma again, and boom, my IntelliSense has popped up again. So next, we want the access type. Okay, so this is kind of like, do I want to look locally to resolve the name locally? Do I want to pull it from the registry, pull it from a proxy, that type of stuff? So for right now, whatever's been pre-configured is what I'm going to use. Okay, so that is internet type. Oh, wait. I think I'm missing a word. Hang on. Internet type. Open? Yeah, open type. Okay. Open type pre-config. That's what we want. Okay. And again, the pre-config, let's make sure I'm not misspeaking here. Let me zoom in a little bit. Okay, pre-config retrieves the proxy or direct configuration from the registry. Okay, so that's what we're going to use. There we go. Okay, so next is that proxy information. Say, hey, do you have any information for me about the proxy? Do you have a pointer to it? We're going to do a bypass thing. So no, we're not going to do any of that stuff. We don't care right now. So these are just going to be null pointers for both of those. Excuse me. And then we don't have any flags to specify. So we just say 0. Okay, cool. So at this point in time, we have set up our, our function call for Internet OpenA to go ahead and say, let's establish the session for our application. Sweet. Now let's error check. So if you remember, Internet OpenA returns null on failure. Okay, null for C is a void pointer. For C++, it's totally different. Okay, I'll talk about that in the C++ series. Okay, so we can do a little check here to say if we don't have a handle to the session, then we know we failed. And then what we can do is we can go ahead and update our last error variable by a call to get last error. Okay, so a lot of Windows APIs will go ahead and set the last error. That way you can get it. Okay, so cool. Now we got the last error. So one of the things we can do with that is we can just print out a nice little status message to say, hey man, the function you tried to call failed for some kind of reason. So I'm going to say %s, and then I'm going to copy the name of the function. I'm going to put it in here and say failed. And then in hexadecimal format, so it's 0x %08x, then a new line. Okay, and then comma, and I'm going to bring this down on a new line, double underscore function. Okay, so double underscore function is basically a macro, if you will, for whatever function you are in currently. All right, so we are in the init session. All right, so every single time this printf executes, the %s will say, hey, init session is where we are. There's also line that's available as well. I think there's also, where was it? A timestamp. Okay, so if you wanted to say, hey, this particular program was compiled on timestamp, you could go ahead and spit that message out too if you want. Right? There's some cool things there. Okay, so the error code, DW last error, sweet. And then once that message is displayed, there's no point to go any further with this. So we'll go ahead and just return that last error. Okay, cool. So let me go ahead and save this. And let me save my header file because I was playing around over there. And let's try to build it. See what happens. Yeah, you're welcome, TPZ. You're welcome. And I did see some kind of issue here. All right. Well, that one's going to drive me nuts. Inconsistent annotation for init session. No. This instance has no annotations. Still, that's insane. It does. Returning uninitialized memory, a successful path through the function does not set. Out parameter. Yes, that is true, kind of, because one of the things that we could do is we could explicitly go ahead and inside our failed routine, our failed check here, we could go ahead and directly update H session to be null, if you will. I mean, it's already going to be that way anyway. Okay, so that's fine. But this is one I wanted you to see. It says unresolved external symbol import internet open A. All right, and it's like, hey, I have no idea what this is all about. And a lot of times you might think, okay, well, why? Why do you not know? It's right there. Just read it. Like, that's where it is. But you go through your checks, right? You go through your checks. Did I include the proper header file? Yes, we did. Absolutely. Okay, we have the proper header file because all those data types are now available to us. The function is available to us as well. So you go back to documentation and say, what's up? And if you scroll down to the bottom, right, it'll tell you the library that this is implemented in, wininet.lib. Okay, so we go back to the code, and there's a few things that you can, where you can take care of this. You can do this in the project settings to add what's called an additional dependency. I'm not going to do that. What I'm going to do here is inside of the header file, I'm going to go ahead and implicitly link against that library file, okay, using a pragma statement. Okay, so the pragma comment is what we want to use. So we'll say pragma comment, and then what we need to specify here is the actual library. So we'll say lib, and then in quotes, wininet.lib. All right, so I save that, and now I'm going to build it and see what happens. Cool. And also, we don't have any of those other warnings either. Nothing about annotations, nothing about successful path not setting the out parameter either. So all that is gone too. So cool. All right, awesome. All right, we have a successful build. Okay. Next, inside of main.c, we need to go ahead and include our custom header file. So we include, and then inside of quotes, we'll do our custom header file. All right. And now we can update our last error variable. So dw last error equals init session. And this is where we can give it a pointer to our H session variable, right? But we haven't made it yet. So let's go ahead and make it. H internet, H session equals null. Okay, let's go ahead and initialize that. And then we'll go ahead and give it the address of the H session variable, okay? Because this is a pointer parameter, all right? We need the address for it. So sweet. I'll just save that and we'll just build it real quick. Okay, cool, build succeeded, okay? There would be no point to running it just yet. Just building out in small changes here, small steps here as we go along the way. Okay, sweet. So if we establish a session, probably the next best thing to do is close the session. So in your header file, your Win HTTP, your HTTP API's header file, well, you can go ahead and make a little wrapper routine around that. So we'll say close session. Okay, so close session, the parameter that we need is the handle to the session. So we'll say in, and we don't need a pointer, all right, because we're not going to try and modify it with any kind of value. We'll go ahead and use H session. Okay, that's fine. It's good enough. Cool. And it goes green because there's no definition for it, obviously. And I'm just going to collapse that. And just to cheat a little bit, I'm going to copy paste. And fill in the parameter. Cool. And then, excuse me, copy and paste the decal annotations. Right. So with the decal annotations, if your function in header file is, let's just say, avoid something and doesn't have any parameters. Okay, so no parameters for a function means you don't need to use decal annotations. Okay, it'd be pointless. Okay, the only time you need it is when you have parameters that have been annotated. Okay, that's it. So cool. All right, now to go ahead and make this, there's a function call we have to make to go ahead and close our internet handle. So internet close handle, and then it needs the handle there, so H session. Okay. And if you wanted to, this is a Boolean type function. So you could say, you could wrap this inside of an if statement, and then you could go ahead and get fancy and say, if this function call failed, go ahead and return get last error. Okay, but I'm not going to do that. Sweet. Go ahead and collapse that. Let me save it. And then back here, we'll go ahead and call close session. Cool, we completed that. We open a session and now we close the session. Okay, sweet. Must return a value. Yeah, of course. We'll go ahead and just say return error success. All right, we'll cheat on that one a little bit. All right, just for the sake of time. Sweet. Good to go. Okay, so next piece is we need to go ahead and prepare our request that we're going to go ahead and send. Okay, so the request, we're just going to make a GET request, keep things super simple. Okay, so over in the header file, we'll go ahead and start to prepare this. So double word, Win API, if I can type. What do I call this? Make request, I guess. Sure. Okay, and now this is where you determine what parameters you want your wrapper function to take. Okay, so for example, as you go through, what do you want to be hard-coded? Do you want this to be a hard-coded GET request? Or would you like the user to have the flexibility to pass in different verbs like post or trace or head, something like that, okay? So different HTTP verbs. So you could go ahead and add in a parameter to say, you know what, let's go ahead and allow the verb to come in here. Okay, so we'll say in I don't think it really has to be a constant. So LP str, we'll call it HTTP verb. Okay. I'll go ahead and copy that whole thing, delete the annotation. I'll come up here and let's copy use decal annotations. All right, so we allow somebody to specify the verb, okay, so they could change it up a little bit. But what else do we need for this? Okay, so the function we're going to be calling here is going to be internet open request. Sorry, not internet open request. Wow, internet connect. Yeah, internet connect. Okay, so internet connect needs a couple of things. So let's go ahead and first let's make our last error variable. And let's return that. Cool. Now we can go ahead and get ready to make our call here. Internet connect. And just like the other one, it's a macro that expands to A or W. For right now, we're just do A. Okay, it says, hey, I need your handle. I need the handle to the internet, your session, if you will. Okay, so obviously this is going to have to be passed in. So we'll just say H session. We'll fill it out later. Okay, now we need a pointer to the server name. This is going to be the target, right? Where we're going to hit. So because we're testing locally, this can just be localhost. But let's make this function or this wrapper a little bit more flexible, if you will. And let's go ahead and allow the caller to pass in that as a parameter. So we'll say the target. Okay, and then we need a port, obviously. So we'll just say the port. And then username, this is stuff for like creds. So no, we're not going to worry about a username or a password. So we'll go ahead and say null pointer for both of those. And then this piece here, service. This is where you can specify if it's going to be HTTP or HTTPS. And this is just going to be HTTP for right now. So much red. It's all bleeding. Internet service. Okay, you can see there's others like FTP, Gopher, whatever, so HTTP. Okay, so flags. Okay, so flags can indicate if you want this to be SSL or TLS type of stuff. I believe is what you can start to specify here. We can do more on that later. I doubt we get time for that. Okay, so no, we're not going to specify anything there, so just 0. All right, in the context, nope, we don't care about that either, so say 0. Okay, now if you want to get picky with these, the flags parameter is a double word, which is an unsigned long. So you could go ahead and do an uppercase UL right after that 0. And with this being a double word pointer, if you were to look at that, I think the root type is unsigned long. So you can say ULL to go ahead and force that. Okay, cool. Now we need to make that red go away, and we're going to take those in via parameters. So we'll go ahead and say H internet, H session. We're going to let that one come in. Now the target, let's go ahead and say this is going to be a pointer, a long pointer to the string, call it the target. Now the port. Okay, so the port, you may have seen the type being internet port. So we'll go ahead and type in internet port. Let's call it the port. Okay, cool. I think that's probably good enough for this one. We have session, target, the port, verb. one other thing that we're probably going to have to take account for is eventually we're going to have to send something back to the caller, and that's going to be handled to the request that we make. Okay, so let's add in one last parameter here. This will be an out parameter. I'll show you that in the header file in just a second. This is going to be LP H internet. We'll call it H request. Okay, so now let's go ahead and let's go to the header file and make everything right there. Make it all up to date. Just going to copy and paste to save a little bit of time. Also possibly avoid errors. All right, so that's going to be read-only coming in. Same with that. It'll be read-only. Same with this one. Except for this last one. Out. Cool. All right, so we got 4 ins, 1 out. Okay, so now back in our C file here, Internet Connect, we didn't assign a variable for this. So as of now, we have no way to tell if this function call fails or, specifically what the last error was. So we need to take care of that. Can I paste the printf statement? How did yours get messed up? That was forever ago. I guess. Should let you figure that one on your own. All right, there you go. That's the one you want, right? Well, if that's not the one you want, that's the one you got. Okay. All right. Cool. All right, so back to Internet Connect A here. Okay, so Internet Connect A, if you hover over it, the return type here is H Internet. Okay, so we'll go ahead and create a variable for that. And I'm going to do a shortcut, H Internet. Okay, this is the handle to the connection, right? So this function call actually won't send anything out to the target or the port, but we are preparing. We are preparing to make that request. Okay, we'll get there here in just a second. Okay, so cool. Now we have that. Now we can do our error check. Okay, so similar to how we checked the last handle, we're going to say if we don't have a connection handle, then we go ahead and save off what the last error was. So we call get last error, and then we update our last error variable. Then we could go ahead and use that printf statement again, but we just update it. Internet Connect A failed with whatever the error code was. And we can go ahead and return that last error. Cool, so I'm just gonna save it. I'm gonna build it, see what happens. Okay, cool, as expected, we have some unreferenced parameters. Cool, so far so good. Let's go ahead and reference some of those parameters. Yeah, you're welcome, TPZ. So sweet. Now, formally on to the request. Okay, so we have our connection handle. Sweet. Now let's go ahead and make our request to a specific resource that the target is hosting. Okay, so here we'll go ahead and dereference the hRequest pointer. And now we go ahead and make our function call here. And this particular function, HTTP open request, A, is named a little bit differently. So we've been using functions that start with the prefix or start with the word internet. Internet, thinking, WinINet as part of the WinINet APIs. This one completely different naming convention, is not part of the Win HTTP header file, despite what the name might make you think. Okay. All right, so we're still using WinINet. Okay, there's no gotcha. We're using both libraries at the same time. Okay, first parameter here is our connection handle. So we know we're good. All right, we did our error checking. We know we should have a legit connection handle, so cool. This is where the verb comes in. And this is coming in as our parameter. So HTTP verb, go and pass that in. Okay, and now we need a pointer to the object name. The object name is kind of like the resource, if you will, of what we're going to go ahead and try and target. To keep things simple, I'll just go ahead and say root. Okay. You can specify other things if you're trying to get a particular file. For example, a little teaser here, if you're trying to download a sliver agent, you can say good.wolf, something like that, right? I forget exactly how they spell it, but you could do that, okay, to go ahead and download it. We'll just say root, right? So give me the root page. Okay, so the version, refer, accept types. Right now, don't care about those. Those are all null. Okay, so null. Excuse me. All right, so flags. We don't care about these flags either. And we don't care about the context for this either. We're pretty much good to go for this particular function call. So say 0 UL for unsigned long, and 0 ULL for unsigned long. Let me go ahead and complete that. And of course, we have to do our error checking, don't we? So I'm going to copy and paste this. And we're just going to modify a few things. It's not the connection handle we're checking anymore. It's the request handle. And we update the name of the function to say HTTP open request A, and everything else pretty much stays. Save and build. Sweet. All right, so we referenced all of those parameters, and we're good to go now. We made our connection handle. Now we made our request handle. Okay, so but still, we did all that work, and nothing has gone out yet. Nothing on the wire has left. Okay, so let's get back. Oh, why is this underlined? Yeah, whatever, that's fine. Don't even worry about that one. All right, cool. Let me minimize that. Minimize that. All right, we can take care of that if we wanted to, but just for the sake of time here, we'll press on. Sweet. So we need to update this, don't we? Okay. So now we need to make our our call to make request. Let's actually go ahead and make it. Okay. So in this session here, we saved that off in a local variable. Last error. We could do error checking here if we wanted to, but don't want to right now. I'm going to cheat just a little bit because technically error handling is done. It can be done inside of these wrapper functions. All right, I'll talk about that a little bit more here in just a second. Okay, so let's update last error with our call to make request. All right, so we need the handle to the session. And now we need a pointer to the target. Okay, let's go ahead and give it that. Okay, so let's come up here. Let's create a new local variable. Let's just call it the target, LPSTR, the target. And we'll say HTTP:// 127.0.0 1. Okay, some of you might be familiar already with these API calls. You might be screaming at your screen with a possible error here, but just bear with me while I want to show you something. All right, so internet port. Okay, so internet port, the port is going to be 8080. Okay. And then our, see, this is why it's nice, or why I like to have the split view here. I can go back to my header file and make sure I have everything in order. Request handle, yeah. All right, so H internet, H request. Okay, so we should be good. All right, so this is where we say the target. Okay, so the target, the port, the verb. Ooh, I missed that one. LPSDR, the verb equals get. Okay, and you don't have to make all of these in variables, okay? Like for the verb, if you wanted to, you could just say get right here, okay? Okay, so cool. We've got the verb, and the last piece here is the pointer for our request handle. Cool. All right, everything looks kind of good. Where was HConnect declared? That was inside of one of our wrapper routines. That's inside of this make request. And expand it out. Right here at TPZ. One of the first things we did. Okay, we'll go ahead and make our connection handle. And then with the connection handle, we pass that to go ahead and prepare a request. All good? No, we lost TPZ. All right, assuming you're all good, I'm going to press on. Sweet, cool. All right, save, build. See what happens. Lost? Hit me with it. Let's get you found. Where are you? Are you at make request? While you're typing. Paste that in, just in case that's where you are. Okay, so just in case that's where you are. Okay, so in case you're missing a lot under make request, I went ahead and just pasted it in there for you. All right, so you should be good with that little snippet. All right, so to summarize real quick where we are, we're making a wrapper function around a couple of function calls, okay? Yeah, I got you. Coming at you. So this make request is going to be a wrapper around two things: the Internet Connect and the HTTP open request. Okay, and the parameters that I decided to have come into this give some flexibility for whoever wants to call this. Okay, so we pass in a couple of parameters for the connection handle and then a few more parameters for the actual request that we want to make to say, hey, I'll let you choose if you want to do a get or like a post. Okay. There are some other caveats for this, though, so it's not completely flexible, but we're getting there. Okay. All right. Cool. Yeah. No problem. No problem. Sweet. So make the request. Awesome. Let's now go ahead and run it. Okay, let's see what happens when we run this thing. So I'm going to hit F5. What we got? It's a code 0. Okay, interesting. Oops. All right, so on my box, I'm just going to spin up a little local Python listener. Okay. HTTP.server module hitting on 8080. Okay, serving whatever happens to be in my documents. Okay, let me go ahead and hit this one more time. Okay, so we got nothing. Okay, so what we could do is we could go ahead and make some printf statements, some more printf statements to kind of say, hey, this is where we are inside the program, right? So let's go ahead and let's do that here. Let's see. All right, so inside here, we can just say %s, because that's where I'm going to place the placeholder for my function, the name of the function, making the request. Okay, so making the request. And then inside of make request, we can say making the connection handle. All right, this is just optional. You don't have to do this. Okay. Oops. Okay, so that is making the request handle. All right, I'll come down here and I'll just say done. %s, done. And function. Okay, build. Okay, good. Check something real quick. Says startup project, cool. Okay, I'm gonna run it. Let's just see what happens. Okay, how about that? And one of the things I want to do now, though, is let's debug this. Okay, let's just step through this one little wrapper function at a time. Okay, so the init session is kind of basic, if you will. We're just using our user agent string, blah 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 blah. We got our session our session handle initialized, awesome. But let's go ahead and jump into make request. Let's set up a breakpoint right here on Internet Connect Day. Okay, so now we're there. I'm going to F5. Cool, there we are. It's taking a minute. Sweet. All right, got all the windows open. Cool, we got memory, we got registers, and of course we have local variables down here at the bottom, bottom left, and we have paused execution right here at 65. Okay, so I'm gonna go ahead and step over this. And HConnect. HConnect we see has been initialized with a value here. And for those that know what handles are already, you might look at this handle value and say, there's no way. There's no way that's a legit handle value. And you're kind of right in a sense that it's not your typical everyday handle, like a process handle or a thread handle or like a handle to a registry key, right? This is just a little bit different, which is why you can't call the same kind of functions you normally would with other types of handles like close handle. Okay, we had to use a specific API to go ahead and close these internet handles, right? And I already showed you what that one was. Okay, so we have that. So awesome. We also have our session handle made. Sweet. We can see the verb coming in, and we can see the target rolling in. Awesome. Let's go ahead and step. All right, so let's go ahead and make the request. See what happens here. So we dereference HRequest. Awesome. We see that it has a value there too. So cool. And we'll go ahead and step that one out, and we say done. Okay, sweet. Then I'll just go ahead and let it run. Okay, so sometimes I like to go ahead and just step through that a couple of calls at a time, just to see how things are progressing along, and also making sure that the variables hold the values I kind of anticipate them to hold or I expect them to hold, not just bogus garbage data. Whoa. Can you copy, paste, make request again? What for? It's already there. I just added printf statements. You don't have to have those. All right, you can add those in on your own. Should be good. Cool. You didn't get all the printfs, that's fine. That doesn't matter. Yeah, that's fine. It's just printfs, no big deal. Okay. So sweet. Okay, so again, nothing has been sent out to the server. Okay, so there's no GET request or anything like that that's come through yet because we haven't sent it out yet. Now we actually need to. Okay, so now we can go ahead and make a wrapper around sending off the request. So say double word, win API, send request. Okay, so because we're making a GET, we don't really technically have to send any information or any data to it, right, to the server. Okay, so thinking as far as what parameters might we need for this, we can go ahead and just say we just need the handle. Okay, we need the request handle. So we say hinternet hrequest. All right. Oops. That needs to be in. I'll go ahead and copy that. And now we can go ahead and make the implementation. Say use decal annotations. Okay, cool. And then just like pretty much every other function, we start off making our last error. And we return that. Sweet. So let's talk about this send request. Okay, so the function that we're going to need to call here is HTTP send request. There's two versions. There's send request and there's send request extended. Okay, the extended requires a specific structure filled with data, does some other things in the background for you, like handling the response that comes back and stuff like that. I can show you that at a later time. But for now, just trying to keep it simple with this example of making a GET request. Okay, so let's go and get this ready. HTTP send request A. The first thing it needs is a handle, a request handle. So let's go ahead and give it that. That comes from our function parameter. And then headers. Okay, so this could be any headers that you want to add on to this request. So if you are trying to send like JSON formatted data, for example, you would have to specify specific headers, specific information to go and say, hey, the content type, stuff like that is going to be formatted as JSON, so on and so forth. Okay, but for this simple example here, we're just going to say, nope, we don't have any headers, and also therefore we don't have a length for our headers. Okay, so optional and optional length. This could be the actual data that you might send off in like a post request, for example. So we're not doing a post request, so we don't have any optional data, and we also don't have any optional length. Okay, so sweet. So we made the call. We're about to make the call. But what we should do is we should go ahead and save this off in a local variable that we can check against it for any kind of error. So hovering over send request, it's a Boolean type. So let's go ahead and make a local variable there for BRET. And I'll do a little error check here. So if we don't have success, then obviously something went wrong. So make a call to get last error. And then we'll do a printf. I'm going to copy and paste that from somewhere else. Okay, I want to make sure update the function name. Everything else should be good here. Okay, sweet. So when this function gets called, that's when you should see packets flying on the wire to the server or to the target and the port. Okay, so let's go ahead and make sure it's saved, make sure my header file is saved. This even talks about annotations. Oh, goodness. Whatever. All right. Let me go ahead and get rid of that breakpoint. Okay, awesome. Make request. Send request. And then we'll go ahead and pass in our request handle. All right. So I'll save that, and let's see what happens. Let's hit F5. Moment of truth here. Uh-oh. Oh no. Send request failed. What? What's up with that? And that is that's an error message there for you. 2EE5. Huh. Well, it's interesting. Let's see. Oops. Will my calculator open here? No, it's freezing. Oh, goodness gracious. Don't die on me now. Did anything come through? No. Right? Was anything on the wire? Hey, you doing? No, because I wasn't capturing anything. No, just to show you that there shouldn't be anything there. Okay, so yes, it failed again. Yeah, nothing. Okay, sweet. So let's try to figure out what in the world that 2EE5 is all about. Okay, so yes, we saw something failed, but now we need to take an error code and actually translate that to something that we could use, right? I don't know what 2EE5 is. I haven't memorized every single error code or error value. It's insane. Okay, so here we're going to make, since we're talking about wrapper functions, let's create a specific function to handle when INET errors. So Solution Explorer, let's add a header file. And because we're dealing with errors, let's just call it errors. If you wanted to, you could call it error APIs. If you want to do that, it's up to you. Okay. All right, so inside of error APIs, one of the things we'll have to do is include, include Windows and standard I/O. Some of you probably wondering, say, hey, Jonathan, you're including some very common header files in all of your things. Is there a better way to do that? Yeah, you can make a header file of your common header files, and then you just include that. Okay, a lot of times you'll see a naming convention of like common.h because that is all of the common headers that typically a program is going to need. Okay, so we could do that here. So yeah, we got windows.h, we got standard IO. Now what we need to do here is make our little wrapper. I'm going to say this one's void because I just don't care about return value for this one. And I'm going to call this check last INET error. And I'm going to make this specific to when INET errors. Okay, so show you how that looks here in just a second. Let's see. I'm showing you a lot of ASCII. Let's mess around with Unicode for a second. So a long constant pointer to a W string. Okay, so LPCW str. This will be the message, or really, yeah, the message you want displayed for the error, or like the function name that failed, or what have you. The next thing that we need to take in is the actual error code. Okay, so this is going to be the last error. Okay, cool. Now let's go ahead and make our implementation of that. So get rid of the CPP, and say errors.c, and let's include that header file. Sweet. And let's start to implement everything. Let's copy and paste. And of course, we need to use the decal annotations. Okay. All right, so for this, this wrapper function around errors, how to handle and actually, make sense of what a last error code actually is. We're going to utilize a function called format message. And format message takes a couple of parameters, obviously. So we need to set up some local variables here. One of them would be the base length. So DW base length. Initialize that to 0. And then we need a buffer to go ahead and store the message that the API is going to give us. So because we're going to deal with Unicode. Say this is going to be a WCHAR array. And a lot of times I use the prefix SZ to say this is a 0 terminated string or like a null terminated string. I'll just say this is my format buffer. And we could go ahead and give it a size if you wanted to. Okay. This value right here, 1024, is kind of arbitrary. You also say this is a magic number, and I hate magic numbers. It would be a lot better to go ahead and take this number out and say define buffer size. Okay, something like that. Then we take buffer size and put that in there. Okay, it just makes things a little bit more readable when you're going through this. Okay, sweet. Now we can go ahead and prepare the call for format message. Okay, so format message, start typing it out. This time, okay, because we're using ASCII for all the other functions, let's use W for this one. Oh, come on. Wanted to show you the IntelliSense, all that. Okay, so the first thing here is the flags. Okay, so the flags here will indicate and say, hey, where am I going to look for this particular error code? Do you want me to look in my internal system buffer for this, for my system tables? Do you want me to look in a specific handle, like a DLL, for this particular value? And that's what we're going to use. We're going to use a DLL to say, hey, I want you to format this message from a module. Okay, so format message from H module. Okay, so cool. So the next piece here is we have to actually provide it a handle to the module. So to do that, we call get module handle. So get module handle W. And it says, hey, I need a module name. All right, LPCW str, long pointer, long constant pointer to a wide. So to do that, we say L, uppercase L, and then double quotes. And then this is when inet. So we say when inet DLL, when inet.dll. Okay. And then the next piece here, now we have the handle. Now we need to go ahead and give it the actual error code that came through. So that's coming through in the parameter of last error. Okay. Next piece here is the double word value for the language ID. Okay, we're not going to give it one. Don't need it, right? Then here, we actually need to provide the buffer. So format message is going to write into this buffer. Okay, so SZ format buffer. Why does that keep going away? And then here we have a double word value for the size of the buffer that we're going to be writing to, or that the function is going to be writing to. So we have that in format of a pound define. Okay, if you don't want to use that, you can do size of. Okay, you can do size of. And then the last piece, we don't care about it, so we just say null. Okay, so now, assuming everything works just fine, we can go ahead and print out the message that it has for us. Okay, so wprintf, you need to do the uppercase L and then your quotes. Okay, so I'll do %s. Okay, so this will be the placeholder for the message that's coming through for the LP message. And then this next %s will be for that translation from number to an actual like string. Okay, so let's go ahead and say LP message, and then our format buffer. Okay, so we got the header file, got the source code file, and just gonna build it real quick here. Cool. All right, so now I'm gonna go into main, and we need to include our error header file. All right, so now we have access to that. Okay, so we can bring that there. We can use that now inside of main. We also could optionally bring that into our HTTP wrapper and do that specific error handling and format message here. But I'm not going to do that. I'm going to go ahead and do that here. So let's see. Just to show you, right? How you want to do this is kind of up to you. So if error success does not equal DW last error, that means something went wrong here, okay? So what we can do is we can say check last INET error, and the message I'm going to say is send request bombed. All right, whatever. You can say whatever you want. And then we pass in the error code. And then you could go ahead and return that error because there's no point to really go on any further. Okay, so I'm going to build that, see if things are good there. And let's run it and just see what happens. Cool. All right, it worked. Hey, so we now know what error code 2EE5 is all about. We know that the URL is invalid. And say, well, why did it let us get so far to finally tell me the URL is bad? I don't know. I was not the designer or not to implement, wasn't the person who implemented those APIs, okay? So now you know specifically, though, what went wrong. So we can come back up here to the target and look at this. So the reason why it's saying the URL is invalid is because we don't need that HTTP funny business, okay? You don't need it at all. So I'm just gonna give it the dotted decimal IP address. You could also just say, you could do the triple W's, www dot whatever, right? Google.com, DuckDuckGo, Apple, which is having an amazing developer conference right now. Some cool stuff coming out apparently. Well, yeah. So we'll go ahead and take off the HTTP, save that, and let's see what happens now. Oh, come on, it's gotta work. All right, sweet. So we got success. Let's see what's on the wire. Oh, get real. Okay. So in any case, I think I was sniffing on the wrong filter, but the GET request did come through. Okay, so let me go ahead and stop this because I do want to show you this in Wireshark. Loop back, that's what I want. All right, F5. There it is. Sweet. So here's why I like to have Wireshark up and running when I am doing any kind of communication over the internet. Okay, even if it's from localhost or whatever, it doesn't matter. You could very easily change this to an IP address somewhere else or an actual www.resource. Okay, so you go ahead and see Wireshark recognizes the traffic as HTTP traffic. Awesome. Okay, so you can go ahead and click on that, packet, and we can see that it is indeed a get for root localhost on 8080. Sweet. And you see the user agent is there. You could go ahead and validate to make sure the user agent is actually correct, so on and so forth. Okay, so cool. Now, what came back? So you notice on the C side, I didn't handle anything that came back. Okay, we just kind of said fire off and forget about it. Who knows what happens? So here's what actually came back, though. Let me stop that. Okay, this is all the stuff that came back. We get the doc type, HTML, public, blah, 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 and a bunch of other things. Okay, all right. So what we need to do now, and what we need to do rather quickly, coming up towards the end of this segment here, is we need to go ahead and process the results that came back from the server. Okay, so let's go ahead and let's make yet another wrapper function. Excuse me, we'll have this be our last one here. Let me minimize that. And back in our HTTP API's header file. All right, so this wrapper, I'm going to call it process results. Okay, so process results really doesn't need to have too many parameters. In fact, I bet you we could get away with just having one parameter, the request. Yeah, should be good there. This will be in. Okay, let me copy that in the source code over here. Go ahead and implement it. Oh, that's not the one I wanted at all. Use decal annotations. That's what I needed. Sweet. So, process results. We need to figure out how in the world to get this back, and we also probably will need a buffer to store this data. And we don't know really how much data is going to come back either. So there's a couple of things to think about and to account for when you're trying to process the results coming from a web request. Okay, so let's go ahead and initialize a few variables here. So last error success. Go ahead and return that variable. Okay, cool. And then a few things to give it. We want to know, or it's going to want to know, how many bytes does it need to read? And then it can also tell you how many bytes were successfully read. So we can go ahead and create those. So DW bytes to read. And we could let's just use 1024 for right now. And I don't think I have that macro handy over here to avoid a magic number, but whatever. Okay, and then the next piece we'll create will be the variable for the bytes that were actually read. So bytes read, just initialize that to 0 for right now. And then we need to make a buffer. All right, so the buffer here will go ahead and hold whatever data comes back. It doesn't care the data format really right now. That's why I have it as a void pointer. All right, I could do a cast if I need to later on down the road. Okay, there's a few things that you can think about for that right there. And if you know what is coming back, let's say you're hosting a DLL, because you want to reflectively load a DLL, then maybe you will already know how to treat those bytes, okay, those raw bytes of a DLL. Okay, when I get to the C++ series, I'll tell you about my favorite data type to use that's really versatile, really flexible, and is great for holding bytes from a DLL that you're going to manually load. Okay, so in any case, we have our pointer to buffer. So now let's dynamically allocate something from the process heap. So LP buffer, and then let's go ahead and call heap alloc. We'll get the process heap. And I want to make sure everything is zeroed out. So heap 0 memory and size 1024. Okay, 1024 ULL. Error check. Always error check, especially with memory allocations. So if we don't have a good buffer or a legit pointer to the buffer, then we can just do something simple. All right, we can go ahead and return last error. Okay, you could optionally go ahead and say, no, I'm gonna update my last error variable to get last error. I'm gonna make a printf statement, and then I'll go ahead and return. Okay, so I'm just doing a shortcut right here, just because we're running out of time. Okay, cool. So now, assuming that we're good to go, let's go ahead and start processing and getting ready for this data. All right, so we're going to come in here and do a forever loop. There's a few ways that you can go about with this logic here, but we'll do a forever loop. Change that to an uppercase true. Okay, and then what we're going to do inside this loop is we're going to go ahead and keep reading from our handle as long as there's data to be read, or until we kind of like hit the cap, if you will. Okay, there's a few things you can change with this. All right, so internet read file. All right, so internet read file, of course, needs a handle for your request. Right, that request handle is the one that actually connected to your web server. Okay, so we specify that there, and now it says we need our pointer to the buffer. Okay, cool. So we give it that. Next thing, number of bytes to read. Cool. Let's go ahead and just give it that. Bytes to read, 1024. Then we need a pointer to the number of bytes that have been read. And so DW bytes read. And we'll close that function. And clean up those parentheses real quick. All right, just to make it a little bit more readable, in my opinion. Okay, so internet read file can happen at chunks at a time, or you could set a very large buffer and try to read everything at a time. You could also implement some kind of loop like this to go ahead and try to keep on looping over while there's something, but it's kind of, we're going to cut it off intentionally here. All right, if something goes haywire for whatever reason, we'll go ahead and just say return, get last error. So if you're going through and you're wondering, okay, when am I done reading data? How does it know? So eventually, DW bytes read is going to be 0. Then you could go ahead and break on out. Okay, again, there's multiple ways, multiple changes you can actually apply here to just go ahead and keep on reading to pull down a sliver payload. And sliver payloads, if you haven't seen them before, are quite large, right? On the scale of like megabytes. right? 15 megabytes, sometimes even larger. Okay, so inside of a loop like this, I can also go ahead and adjust the size of my buffer to reallocate and expand it. Okay, that way it can keep growing as I need it to grow, right? That way it can hold the entire payload. Okay, so in any case, should be good just to go ahead and show off the first 1024 bytes of whatever's coming through. So I'll go ahead and make my printf statement to say, let's just go ahead and dump results. And that will be the function. And then this printf here will go ahead and be the actual results from the buffer. Okay, so LP buffer. Sweet. Okay, so at this point, we have to make sure that we clean up after ourselves. So I'm going to do a little check. If LP buffer, and we need to free it. You know, open up our process heap handle. 0 is fine there, and the buffer that was allocated. Okay, so we free it, but we need to take care of that pointer. Now it's dangling. Okay, we don't want it to dangle. We need to go ahead and reset it. Reset that and basically reassign that to be a null pointer. Okay, so let's see what happens when I compile and just build this thing out. There we go. Sweet. Okay, so it says if the format string %s requires an argument of type char star or LPSTR or PSTR, whatever. But it's like, yo, you have void. Well, there's a few ways to take care of that. One of the things that you can do is just say LPSTR. Okay. Nope, not LL. Okay, you can say LPSTR. You could also say LPC STR to say this is a constant because printf really won't be needing to modify anything in this buffer. Okay, so it built. Now let's run. See what happens. Okay, it's good there. that was old. Let me redo it. Okay. There you go. Yep. There's the traffic. Okay, looks good. And let's see. Got a resource we're getting hit. Awesome. Let's see here. Okay. And I missed it. We didn't actually call it. So silly. So silly me make that mistake. Oh well. Let's see. There it is. All right. Cool. That's processing the results. I came back. Awesome. Okay. So the results look ugly, but that's exactly what it is. Okay. So that's actually the result from my little Python web server here, hosting whatever it happens to be in my documents folder. Okay. So we barely made it, I think, just at top of the hour here. Just want to summarize real quick what we did. Okay, so we established a session handle for this program to access things over the internet using WinINet. We specifically crafted a request to a target and to a port, and the verb we chose to use for now was get. Okay, and then we went ahead and sent that request off to the resource, and we eventually process the results. Okay, so this is pretty bare bones, right? There's a lot of enhancements that you can do to this. And maybe in part 10, I could show you quickly what a more enhanced version of this could look like. But we'll go ahead and wrap it up here. Let's see. When there's a break in connection, can you continue where you left off? As far as breaking connection, you mean if the NIC goes down or something like that, internet outage or whatever, something like that? If that's what you mean, that's possible, but definitely a little bit more code to do. But yes, it's possible. But yeah, good question. Thank you everybody for jumping in for part 9. Be looking for part 10 to be scheduled. We'll move away from HTTP things and probably move over to sockets and stuff like that. All right, hit me up on Discord if you all have any questions. Again, thanks again for everything, and you all have a great day.